This is 8.3 notes, sine ratio. So the last section of notes, we learned about a tangent ratio and how the tangent ratio was equal to an angle's opposite side divided by its adjacent side. So sine ratio is similar, just a different ratio using different sides of the right triangle in comparison to the angle in which we are referencing. So our essential question should be, we need to change that to sine ratio, and how can we use it to solve for missing sides in right triangles? So again, everything you see here needs to go in your notes. The sine ratio is the ratio of the opposite side of an acute angle in a right triangle to the hypotenuse of that right triangle. So here is the formula that you definitely need to know. So we have the sine of some acute angle, angle theta, is equal to opposite angle theta. So this means the opposite side to that angle divided by the hypotenuse of the right triangle. So if we're looking at this triangle here, you can see this is the angle we are referencing down here, angle theta. You can see that this side is opposite to that angle. It's across from the triangle. And this side is the hypotenuse right here. This is going to be our hypotenuse. It is always across from the right angle. That's how we know what the hypotenuse is. So the sine of angle theta is equal to the opposite divided by the hypotenuse. And we're talking about the sides of the right triangle. Moving along here. Finding the sine ratio in a right triangle. So this is very important. When asked for the sine of an angle, you are not being asked for the angle measure. You are being asked for the sine ratio of that specific angle in the triangle. The sine ratio of any acute angle is that angle's opposite side to the hypotenuse. So let's practice this a little bit. What is the sine of angle C? When you are asked that question, I know it feels like when I ask you what is the sine of angle C, your brain kind of automatically thinks that we're talking about measurement. We are not talking about measurement. What I'm asking you is, what's the sine ratio of angle C? Okay, so angle C is this angle up here in this corner, angle C, and we know that the sine ratio, sine is equal to opposite divided by the hypotenuse. So the side that's opposite angle C is 8. It's across the triangle, that's opposite. And the hypotenuse of the triangle is 10. How do we know that's the hypotenuse? The hypotenuse is always across from the right angle. So therefore, the sine ratio is 8 over 10, which reduces to 4/5 after we divide it by 2 over 2. Always reduce. So the sine ratio of angle C is 4 over 5. Next question, what's the sine of angle B? Well, angle B is just simply the other angle. Let's use a different color. So angle B is down here. But again, so we say the sine of B, that means angle B is the opposite side to angle B divided by the hypotenuse. So the opposite side to angle B across the triangle is 6. And the hypotenuse is still 10. The hypotenuse does not change. The opposite side changes though. So we have 6 over 10, divide both by 2, and we get 3/5. So you'll notice that what? The sine of angle C, right, is 4/5, but the sine of angle B is 3/5 because they both have different opposite sides depending on the angle in which we are talking about. Let's keep on moving. Let's do a couple more specific examples. Copy these into your notes, pause the video and rewind as much as you need to. So it says, let's use the sine ratio to find the length of missing side BC. So we're going to use this 40-degree angle right here that's given to us, this angle. And we're going to use the sine ratio because the side that's given to us is the opposite side to 40 degrees, and the side in which we are solving for is x, which is the hypotenuse of the right triangle. So since we're given the opposite side and we're solving for the hypotenuse, we want to use the sine ratio. So we say the sine of angle C. Why angle C? Because that's the angle measure that they're giving us, was angle C. If they gave us angle B, we would use angle B. So we say the sine of angle C is equal to that angle's opposite side divided by the hypotenuse. Well, we know the measurement of angle C, it is 40 degrees. So we're going to say the sine of 40 degrees is equal to the opposite side, which is 14, divided by the hypotenuse, which is x. And now all we have to do is solve this equation. The sine of 40 degrees is a funky decimal number that your calculator has memorized. So I'm just going to take my calculator and I'm going to type in 40 and the sine of 40 degrees. And at this case, we are going to round our decimal to 5 spots. So I'm going to say 64278. And I'm going to say 64279 because that's what it rounds to correctly. So I'm going to say 0.64279, that's the decimal that I got, is equal to 14 over x. And I can make this decimal into a fraction by putting it over 1. And then we're simply going to solve this equation by cross multiplying. So I'm going to get 0.64279 times x is equal to 14 times 1, which is simply 14. And then we're going to divide both sides by 0.64279. That's going to cancel. And this is the answer we're going to get. So I'm going to say x is approximately, because we did already round this number, right? So I could keep this number in there if I wanted, but that's okay. I can just use the 5 decimal places. So I'm going to say 0.64279. Actually, I have to say 14 first. Let's clear. So I'm going to say 14 divided by 0.64279 equals 21.78 or 21.8 if we round it to the 10th place. So I'm going to say about 21.8 inches is the length of that side x, the hypotenuse. Last example for our notes. Again, you must copy this down, and this must be in your notes. So we're going to again use the sine ratio. Why are we using the sine ratio? Well, we're given this acute measurement of angle, which is 23 degrees. The side which we are solving for is the opposite side to 23 degrees. And the side that's given to us is the hypotenuse, because it is across from the right angle. Therefore, we use the sine ratio, because the sine of any acute angle, or angle t for that matter, 23 degrees, is equal to the opposite side of angle t divided by the hypotenuse. So we can clearly see that 23 degrees, that's angle t. We're going to plug that in there. The opposite side to angle t is x. That's what we're solving for. And the hypotenuse, which is given to us, is 13.4. So we're just going to plug that in there, and then we're just going to work this out. So we're going to say the sine of angle t, which is 23 degrees, is equal to the opposite side, which is x, over the hypotenuse, 13.4. So the sine of 23 degrees is a funky decimal ratio, so I'm just going to punch this into my calculator and figure out what that is. So sine 23 degrees. And then I'm just going to round that to 5 decimal places. So 39073 is good enough. So 0.39073 is equal to x over 13.4. We're going to put this decimal over 1, and we're going to solve this by cross multiplying. So 1 times x is approximately, because we already rounded, so it's not an exact answer, but it's very close. So we're going to say 13.4 times 0.39073 And we get 5.23, or just 5.2. So x is approximately 5.2 inches. That is the length of this opposite side, approximately. And that's how you're using the sine ratio to solve for missing sides in a right triangle. You're dealing with the opposite of the given angle and the hypotenuse. So in your summary, do a great job. Skip a line, write summary. How can you tell the difference between the opposite side of an angle and the adjacent side of that same angle? And maybe give us a picture of the example of what you mean by that.